So let's look at triangle proportionality. I want you to notice in this picture that you do have arrowheads. So you do know that this line cutting through the triangle is parallel to this base, and it's noted below the figure. If a line is parallel, and here's our symbol for parallel we've talked about all year, to the side of a triangle and intersects the other two sides, so it's parallel to one side and intersects the other two sides, then it divides those two sides proportionally. It is asking about side lengths. Okay, so let's pull down and let's look at some examples. Let's start here on the left and make it a little less busy. Okay, in example 1, if segment AD is 7, DB is 12, and AE is 3, find EC. So again, we've talked about you can easily redraw the large yellow triangle and the small pink. When you go to set up your proportion, be careful with your ratios. Compare the two sides within the ratio. So this 7 plus 12 is 19 units for the length of the yellow side. That compares to the length of the pink side, which is 7. That's going to be equal to, you have to have an equal sign because we're writing an equation to solve. Your 3 plus x is the whole length from A to C, the 3 up here plus the x here, and that compares, it's proportional to the side that's 3 units long. When you cross multiply, the 3 times 19 gives you 57. The 7 times 3 plus x, 7 times 3 is 21. 7 times x is 7x. Let's move all our numbers to the left side to combine like terms, so subtract 21 from both sides. And you end up with 36 equals 7x. When you divide both sides by 7, you get a decimal answer, which is fine. 5.14 would be x. Okay? So let's look at another example. So I talked about doing a shortcut here. You can come over here and look at the long answer and look at the short one where we just said 7 is to 3 as 12 is to x, and that builds on something we'll learn in a different set of notes about triangle proportionality. But working with the large and small triangle, you can never go wrong. So here, there's no shortcut when you're solving for the base of the triangle in a picture like this. This only works based on what we'll be learning about triangle proportionality later, so always be careful. But here, our green small triangle at the top, our blue triangle, which is large. So we have our 5 and our 8 for the blue. 5 plus 8 is 13, and for the green it's just 5. 5 is to 13. Here it is. AE we're not worried about because we don't have enough information on the right hand side. We're going here to the bottom of the triangle. DE is x, that's on our small triangle, and our large triangle it's 3x minus 4. So we cross multiply, we get 13x for one side of the equal sign. 5 times 3x is 15x, and 5 times negative 4 is minus 20. Then you walk through your algebra to combine your numbers and get x's on one side. Since we have more x's on the right, let's do the opposite of positive 13x is minus 13x to both sides. This cancels. You have 2x. Let's move all our numbers to the other side. Get rid of the minus 20 by adding 20 to both sides. 2x equals 20. Divide both sides by 2. And x is 10. Okay, so let's go ahead and practice a little bit. That was some examples. This is now taking a concept to the coordinate plane. This is supposed to be your origin right here where your y-axis intersects your x-axis. So here we have 0, 0. We're moving to the left, so our x values are negative, and we are on the x-axis, so our y values are 0. Likewise here, our y values do have numbers, but our x values are 0. They want to know what n is. So you're going to set up your proportion based on the lengths here to apply here. So we can say that we don't have to deal with the negatives because we know our answer will be negative just by where it is on the coordinate plane. So if negatives are something you make a mistake with, just be careful here. So we know we have 15 is to 20 as x is to 32. Okay, so 15 is to 20 as x is to 32 if we're looking for this coordinate right here. Cross multiply. Let's go. 20x equals, do the 32 times the 15 to keep it fast, 480. Divide both sides by 20. And that's where we got the x equals 24, right? But we know it's negative 24 because we're going below the origin. So the coordinates 0, negative 24 can be done with our cross multiplication. For our scale factor, we can find any two corresponding values. Let's go with the ones they gave us. Since it said image is MON, image is the big one we ended up with. We started with a pre-image, POQ, the very large triangle. We are reducing. We know our value has to be between 0 and 1, so that's why we can put the 15 over the 20, and that reduces to 3 over 4. Great example of a reduction. Can't tell if something's going wrong.